Early in brain development, the brain is waiting for a set of instructions about how to develop. And we know that adverse experiences can alter the trajectory of brain development, but the worst thing you can do to brain development is to deprive it. And the reason is that it's not getting any instructions at all. So using myself as an example, I just came back from a trip to Europe. I have terrible spatial ability. I'm always getting lost. In fact, I think I may have driven by this building 4 times before I figured out where I was going today. If I'm given explicit instructions, I know what I'm doing. But if I'm not given instructions, I have no idea what I'm doing. And that's exactly how brain development works. Unfortunately, this is going to be a rather sobering talk, meaning I mostly study when terrible things happen to kids early in life. And I'm going to emphasize a few of them, but I'm going to begin with some background. I'm going to talk about 2 categories of things: how experience impacts brain development, and then the second is the effects of adversity on brain development. And within that, I'm going to emphasize 3 things: what we call toxic stress, which I'll define in a little bit, poverty, and then neglect and deprivation. So let me provide some context, rather, for what I'm going to talk about for the next 20 or so minutes. The beginning is that individuality is the product of both biological inheritance and personal experiences. So our genes provide the basic architecture of brain development, but experience then tweaks and refines this architecture. So imagine you've commissioned a blueprint from an architect, and that blueprint, in the case of the brain, basically is initially conferred by our genes. However, the further elaboration of that blueprint is done by experience. So because each individual's genome differs, as well as their epigenome. So their genome would be your DNA, and your epigenome would be basically the expression of the DNA. That differs for everybody, even identical twins. So even though identical twins may have identical DNA, their epigenome, which is how the DNA has been changed or expressed differently based on experience, differs even among identical twins. And because each individual's world is not the same, each brain is built differently. And this is also, again, true for even identical twins. In my autism work, we have a pair of identical twins who have the same rare genetic variant, which leads to a rather devastating neurodevelopmental disorder, but the twins are actually different from one another. So even though they have the same DNA and the same family and the same rare genetic mutation, they're actually different, very different girls. So all of this is by way of explaining that each brain is different from each other brain. Some experiences which are critical to brain development are, or at least should be, universal to all members of the species. So for example, sensory input like seeing patterned light, like faces, or hearing sounds like speech, or having a caregiver take care of you. These all help ensure survival. Other experiences may optimize development. So it's one thing to have a caregiver who changes your diaper or feeds you. It's another who responds sensitively and consistently to your needs, or exposes you to complex and age-appropriate language, or progressively challenges you cognitively as you get older. In many cases, both of these types of experience have to occur during what we call a critical period of development, if development is to proceed in a typical fashion. If during these critical periods certain experiences are altered or are lacking, that can essentially throw the brain off track. So here's a way to illustrate this. Think of it this way. Here's birth. The green bar represents the development of sensory systems like your ability to see, your ability to hear. These would be motor and cognitive functions like your ability to understand what I'm saying and to speak. These would be higher cognitive functions. What this is explaining is that it's during the peak of these periods that experience exerts its biggest effects. And so these windows of opportunity represent the time when brain can be derailed or proceed on a typical developmental trajectory, depending on whether these experiences occur during these critical periods. Many critical periods occur in the first years of life. And even within a domain like language, there may be multiple or cascading critical periods. So in other words, the ability to learn syntax or vocabulary or semantics all has a slightly different timetable. The problem with this model is that experience cuts both ways. So if a child is exposed to adverse experiences during a critical period or deprived of expectable experiences, then brain development can be undermined. And these effects can be biologically embedded and then persist across the entire lifespan. So the point then is that if during these critical periods, typical developmental experiences fail to occur, or if there's a problem with the child's brain, for example, they're born with cataracts or they're born with a hearing impairment, and they can't take advantage of those experiences, brain development can go off track. Those experiences can be biologically embedded, and they can persist throughout the entire lifespan. An example of that is late during the Second World War, there was a famine in the Netherlands for about 9 months. There were many women who were pregnant. The offspring of those pregnancies have been followed since that time, and 50 years later, there were still differences observed in the offspring who were basically malnourished during that period of famine. Examples of adversity that I'll talk about today will include toxic stress, poverty, and neglect and deprivation. So let's start with toxic stress. This is some work that was published a little less than a year ago, and it's designed to illustrate the prevalence of violence perpetrated against kids under 18 throughout the world. So these are figures from 2014. Kids less than 18 experiencing sexual, severe physical, emotional violence. And to bring all this up, you can see that roughly 1 billion children around the world are exposed to these levels of violence in any given year. This does not include corporal punishment. If you include corporal punishment, the figure goes to 1.4 billion. So roughly a third of the world's children are exposed to violence in one form or another in any given year. There was a project that was launched many years ago now called the Adverse Childhood Experiences Study that essentially tried to demonstrate the link between adverse experiences during the first few years of life and what happens later in life. So we'll start with this figure here. We know that more than 40% of all Americans have experienced at least 2 forms of adversity early in life. Adversity can be a divorce in the family, a death of a parent, maltreatment, any number of things. And what this is looking at is the likelihood that a child will have a developmental delay as a function of the number of adverse experiences they had in those first years of life. So you can see here a very steep linear increase, particularly taking off around here, where almost 80% of the children who have had an ACE score of 5 or more have a developmental delay, whereas those with 7, nearly 100% do. So something as simple as a developmental delay in school performance, learning disabilities, things like that, can be tied to the number of adverse early life experiences. If you look here, if you look at alcoholism and illicit drug use, you see something similar. So these are, I think, 30-year-olds who reported having problems with alcohol based on the number of adverse life experiences they had. So if you look on the left side, you'll see that starting with an ACE score of 2, roughly almost 8% of individuals with alcohol will report an ACE score of 2 or more. If you go to an ACE of 4, 16% of people with a problem with alcohol will have had more than 4 adverse events. If you look at illicit drug use, it's the same thing, that nearly 40% of individuals as adults who've had 5 or more adverse life experiences in those first years of life wind up having a problem with illicit drugs. So exposure early in life to chronic, multiple types of particularly toxic stress can have both short and long-term effects on development. Now in this context, let me define what I mean by toxic stress. We think of stress coming in various varieties. Not all stress is bad. Stress has gotten a bad name, so we can have positive stress, a challenge. So I gave an exam to my students yesterday. They have a week to finish this. I'm hoping at the end of this, although there'll be some stress during this week that they're writing the exam, in the end, they'll feel some sense of mastery at the end of that. Tolerable stress would be an adverse form of experience, an adverse experience. For example, a child may get sick and have to be hospitalized for, say, a pneumonia. But they have a buffering relationship. That is, they have a good relationship, say, with their parents or with the nursing staff at the hospital. And as a result, even though they're experiencing stress it's in the context of a warm, supportive relationship, and as a result of that, the stress has no negative effects. But a form of toxic stress would often be a chronic or unremitting stressor with no buffering relationship. So the example here, as I'll get to in just a minute, would be children who have multiple forms of adversity and who fail to have a caregiver who steps up for them. So an example, about 3 years ago I was asked to consult on a capital murder case in Georgia, rural Georgia. It was a young man who had shot and killed his pregnant girlfriend, so he was charged with 2 homicides. He was, the defense wanted to basically argue that he should be committed to life without parole. Of course, the prosecution wanted to execute him. So I was brought in to talk about his early life experiences and with that explain, not excuse, but explain his behavior as an adult. So when he was 4, his father put a gun to his mother's head, looked at the boy and said, "Who do you love more, me or your mother? Choose wisely." When he was 6, he watched his sister murdered. When he was 7, another sister was raped. He himself was abused. By the time he was in his teens, his IQ was hovering a little less than 70. He had PTSD and any number of other psychological problems. And so what I explained to the jury is that given this young man's developmental history, it wasn't entirely surprising that he wound up having problems as he got older. And again, this was not to excuse his behavior, but it was to explain his behavior. According to what I heard, the jury thought I was a really nice guy, but they still sentenced him to death. The short-term effects can be developmental delays, compromised mental function, anxiety, depression, other mental health problems. Long-term effects can be mental health issues, compromised physical health, shortened lifespan. The number of adverse experiences you have as a child can also be related to whether you develop type 2 diabetes and cardiovascular disease. So now let me turn my attention to poverty. So let's start with what we mean by poverty. It's often an income-based definition, varies by family size and composition. A family with 2 adults and 2 kids, the poverty level, I think as of a few years ago, was around $24,000 a year, pretty much about what graduate students make when they're students. There are nearly 16 million children in the US, or 22% of all kids, who live below the poverty line. We know that childhood poverty is strongly associated with different aspects of cognitive development. So kids growing up in poverty they do less well on achievement tests. They're more likely to be retained in grade, to have functional illiteracy, lower IQs, and a diminished high school graduation rate. Again, these are all correlations. So not everyone growing up in poverty shows this pattern, but it shows that there's an association between growing up in poverty and these outcomes. These are some of the neurocognitive systems that we know are impacted by poverty. So on the far left, executive functions refers to these sort of higher cognitive functions. That could be your ability to plan for the future, your ability to inhibit a response, not to say something that would be inappropriate, for example, something that we haven't seen much in this presidential election, or that comment, which just came right out of my mouth, unfiltered by my prefrontal cortex. Memory can be affected by poverty. Visual spatial skills, so your ability to understand spatial relationships, and language. This brain I'm showing you here, the blue here is the corpus callosum that connects the left and right hemispheres. And there's a structure sitting in here called the hippocampus that's very involved in memory and maybe some aspects of emotion. And the little area in purple here is the amygdala, a part of the brain very involved in emotion. So these neurocognitive systems are all highly associated with poverty, meaning that kids growing up in poverty are more likely to have problems in executive functions. ADHD might be an example. Poor memory performance, visual spatial skills will suffer, and language will suffer. So this is some work that's now very widely cited and very, very sobering. This is showing the association between the words that are addressed to the child, that's the y-axis, the number of words the kid hears, and on the x-axis, how old the child is. And if you look here, you'll see that among professional parents, the number of words heard is dramatically higher than working class parents, which is dramatically higher than parents what was then referred to as welfare parents. So the number, complexity, and responsiveness of verbal interactions differs by SES. Kids growing up in poorer families hear fewer words, less complex sentences and language, and less responsiveness, meaning that when the child says something, the parent may not respond to what the child said. The number of words that the child hears is directly related to the child's vocabulary size. So the more words the child is exposed to, the larger the child's vocabulary. We know growing up in low SES households and all that comes with that. So we can't argue that poverty per se plays a causal role in these outcomes. It's all the things that travels with poverty. It's strongly associated with a variety of cognitive and linguistic skills, but there's some recent work that suggests that kids growing up in poverty show greater cortical thinning. So the cortex is the part of the brain that when you look at it, you see those little bumps and valleys. These are called convolutions. And as we get older, we prune the thickness of the cortex, meaning that we start to reduce the number of brain connections among brain cells, or even reduce the number of cells. And this is a perfectly normative process, and it's driven by experience. But what happens in kids growing up in poverty is they over-prune. So the initial observation, which is now a few years old, is that kids growing up in low SES households have pruned away too many brain connections and too many neurons. But what's important is some very recent work that shows that these effects are moderated by caregiving. So kids growing up in poverty who have very responsive and consistent caregivers don't show the over-pruning, which means that it isn't growing up in poverty per se, but it's the quality of caregiving that moderates this. But many poor women who are uneducated and maybe have a lot of stress in their lives may not be the most responsive caregivers, and that's what seems to be responsible for these effects. So let me turn to the last part of my talk, which is what happens when the brain is deprived or neglected. So why is neglect bad for the brain? The way to think of this is that early in brain development, the brain is waiting for a set of instructions about how to develop. And we know that adverse experiences can alter the trajectory of brain development, but the worst thing you can do to brain development is to deprive it. And the reason is that it's not getting any instructions at all. So using myself as an example, I just came back from a trip to Europe. I have terrible spatial ability. I'm always getting lost. In fact, I think I may have driven by this building 4 times before I figured out where I was going today. If I'm given explicit instructions, I know what I'm doing. But if I'm not given instructions, I have no idea what I'm doing. And that's exactly how brain development works. So the brain, in the case of neglect or deprivation, expects input it doesn't receive. So the wiring is altered. This is particularly egregious if the lack of input occurs during these critical periods. So if a child born with cataracts who doesn't have the cataracts removed until 4 or 5 months of age shows a dramatic recovery in how well they see, but they will always show subtle deficits in processing faces because they didn't see faces in those first few months of life. A child who's born with a hearing impairment who does not have that corrected by, say, a cochlear implant in the first few years of life will always have a residual hearing impairment. So the point then is neglect has a devastating effect on brain development. Just to put this in perspective, if you look at all forms of maltreatment, physical abuse, sexual abuse, emotional abuse, and the like, hands down, neglect is the most common form. In fact, in 80% of the cases reported to child protection, neglect is involved. So there are cases of just neglect, and then even in cases of maltreatment like physical abuse or sexual abuse or emotional abuse, often those children are also neglected. So it is a very big public health problem. For the last 16 years, 2 colleagues and I have been trying to understand or model how neglect impacts the brain by looking at a very unique set of circumstances, which is children who are abandoned at birth and then raised in institutional settings. So these are some pictures of the children we've been studying all these years in Romania. Some of you may remember many years ago these horrible videos and still images of kids in Romanian orphanages who had been abandoned there by their parents shortly after the Ceausescu regime was overthrown in a coup in 1989. And a couple of things to note here is the sheer number of kids all crowded together, how few caregivers there are. If you look at the babies, they're all sitting in cribs staring at a ceiling. And so this is a way to look at the effects of profound deprivation on brain and behavioral development. We've known for years that children raised in institutions are at a very high risk for developing a variety of social and behavioral problems. This includes disturbances in social relatedness and attachment, externalizing behavior problems like conduct disorder or attention deficit disorder, deficits in IQ and executive functions, a syndrome that mimics autism, and growth stunting. So let me give you an example of growth stunting. I want you to look at these two kids and think, how old are they, and are they boys or girls? And as you're thinking about this, this is the answer. That's a 17-year-old girl, that's a 14-year-old girl. And probably most of you were thinking that these children were probably someplace between 4 and 6 or 7 years of age. Gender is more difficult. But the point is that kids will lose a month of height for every month they spend in a bad institution. So this is an example of the effects of institutionalization on growth. So starting in around the year 2000, my colleagues and I launched this very ambitious study in Bucharest, Romania, which was the first randomized controlled trial of foster care as an intervention for kids growing up in institutions. We started with 136 kids who had all been abandoned close to the time of birth to any of 6 different institutions in Bucharest. We did an extensive baseline assessment on them, looked at different domains of their development when they were 6 to 31 months of age, and on average they were about 20 months when we randomly assigned half to foster care that we built. There was no foster care in the country when we started, so we had to create our own. And the other half were randomly assigned to remain in the institution. And then we had 72 kids who lived with their families in the city, had never been in an institution. We saw the children again when they were 9, 18, 30, 42 months of age, 54 months of age, 8 years of age, 12 years of age, and we're now about a third of the way through a follow-up when the kids are 16. Now before I go on, let me briefly mention the ethics of this study. The reason we could do random assignment was there was no foster care in the city, in the country when we started, so we had to build our own. There was a strong cultural bias against people having kids in their home who are not biologically related to them. So we had to build our own foster care program. We did extensive advertising and then screening, and after all was said and done, we could only find 58 families that we thought would be good foster care families. Another ethical requirement is we kept siblings together. We didn't want to separate them. So in the end, we only had 58 homes in which we put 68 kids. So we were not withholding treatment. We only had so much treatment to go around. A second issue is that when you're doing a clinical trial, if early on in the study you find big effects, so let's make believe I'm doing a drug trial for diabetes and this half of the room gets this new drug and this half of the room does not. If I look at the data and I find that I have cured your diabetes and there's no side effects, I'm ethically obligated to either give all of you the drug or to stop the study so you're not advantaged over you. But in this case, if we stop the study, we looked at our data, we found a big effect. If we stopped the study, all the kids in foster care would go back to the institution, and there still was no more foster care to go around. So what we did is we called a press conference where we brought the government and the press together and we announced our findings, basically to shame the government into doing something. And sure enough, within a year, they passed legislation forbidding the institutionalization of any child under the age of 2. A third ethical requirement was we have a policy of non-interference. So any kid that remained in the institutional group, if they had the opportunity to leave, they did. A good example of that was the government started coming in and taking kids out to put them in either government foster care, which started later, or reunite them with their biological parents. By the time our kids were 12, of the 68 that started in the institution, only 20 were still in an institution. But all the findings I'm about to share with you are based on where the kids were originally assigned. And the reason for that is that avoids what we call sample bias, meaning that if I assign you to the institutional group and you to the foster care group, and if you start changing, I don't know if you left the institution because you were better behaved or you were a smarter kid. So our findings are actually very conservative because it's based on the group that you were originally placed in. So let me just summarize some of the key findings. IQ, language, executive functions were all greatly diminished in the kids in the institutional group. The kids in the institutional group showed very elevated rates of mental health problems, a dysregulation of their ability to respond to stress, dramatic reductions in their telomere length. So each of our chromosomes has a cap that protects the chromosome as the cells divide. So when you cut yourself and you make new skin cells, every time those skin cells multiply, this cap protects the chromosome. Over time, this cap gets eroded. It's called the telomere region. And we know that stress can accelerate telomere length. So middle-aged women who have taken care of kids with chronic disabilities their whole lives have lost the equivalent of 10 years of telomere length from the stress of taking care of those children. We showed the kids in the institution showed dramatic reductions in telomere length. With very few exceptions, placement into our very high quality foster care, and maybe after we're done we can talk a little bit about what I mean by high quality, led to dramatic gains in function, although often not a complete recovery, but a very large gain. So, for example, they showed a big gain in IQ, an improvement, a reduction in mental health problems, an improvement in their ability to form attachments. But many of these domains were regulated by critical periods. So the kids placed before 2 had better outcomes than the kids placed after 2. So let me give you an example of this. So we recorded EEG, the brain's electrical activity, throughout the study. You place sensors on the child's head. You can see in the upper left is a child in my lab here in Boston. And all you're doing is taking a readout of the electrical activity generated by the connections from one neuron to another, a synapse. And we can color code this so that red represents more brain activity and blue or green represents less brain activity. And what you're looking at here is a view from the top down with the nose at the top and the back of the head at the back and the left ear and the right ear. And all you have to do is look at the amount of red in the never institutionalized group in the bottom versus the lack of red in the top, the institutionalized group. So at baseline, we already see a dramatic reduction in the brain's electrical activity. The way to think of this is that if we had a dimmer and we can make this light brighter and dimmer, the kids in the institutional group had a 40-watt bulb. I guess nowadays it would be a 6-watt bulb. And the kids in the foster care, the kids who've never been institutionalized have a 100-watt bulb. Now let's turn to the foster care findings. So these are now when the kids are 8. On the upper left, CAUG stands for the care as usual, the kids in the institutional group. And the upper right are the kids in foster care placed there after 24 months of age. And you notice those look identical. The lower left are kids placed in foster care before 24 months of age, and the lower right are kids who've never been in an institution, and they're identical. So what that's telling us is that placement before 2 leads to basically a normalization of the brain's EEG, and after 2, it's as though the kids never left the institution. So that's basically what this summary says. When the kids were 8 to 10, we started doing magnetic resonance imaging on them. That's what you're seeing on the left side. On the right side is a side view of an MRI scan. The first observation we noticed was if you look at the brain's gray matter, the gray matter could be the body of the neuron or dendrites. It's anything without myelin. We see no foster care effect. There's a dramatic reduction in the brain's gray matter for the kids in the institutional group or in foster care compared to the kids who've never been institutionalized. But for white matter, now you'll notice that the kids in foster care show a small increase in white matter. So we see a bit of an intervention effect. So what that's telling us is that the kids placed in foster care show no benefits in their gray matter, and our concern is the reason is that they have over-pruned non-myelinated tissue like just neurons, and there's no coming back from that. Once the brain is the only part of the body, only organ that does not generate new cells once injured, unlike other parts of the body. You'll regenerate parts of your liver or your skin cells and the like. The last thing we wanted to look at is how these kids regulate their stress response. We know from a lot of literature with humans and with animals that the ability to regulate your response to a stressor begins early in life when you have a caregiver who helps you cope with those things. So an example would be, a number of years ago, we had a dog, very frisky dog. It was a boxer, very liked to jump on you. The boy next door, who was 4, came out one day and our dog got off the leash. Dad was with the boy. The boy called the dog. The dog ran at this kid. The dog was about as big as this boy, jumped up, clocked this kid, just knocked him right down on the ground. And the immediate response for this kid was, oh my God, this is a vicious dog, blah, 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 blah. But the dad handled it beautifully. Just explained to the kid that Kitty was really friendly. She was just trying to say hello. Kid bounced up, he was fine. So that's an example of how this child would learn to respond appropriately to a stressor. So, the stressor that we did was we asked the kids to prepare a speech about what it means to be a friend. And then we had them give the speech in front of 2 fake teachers who were judging them. So as I look out at the audience, I'm thinking you could be sneering at me right now or falling asleep, and that should make me more stressed. So in the meantime, we're recording their heart rate, their skin conductance, whether they're getting sweaty palms, and a hormone called cortisol, which is released when you're stressed. If children fail to have developed an appropriate stress response, they're going to show the following pattern. Instead of their heart rate going up, they may not show a heart rate response. Instead of their cortisol going up, they may not show a cort response. Their palms may not be sweaty. So the normative response would be slightly anxious, right? So let's just deal with the cortisol response. So here's how this works. We can record all of these parameters during the time the kid's preparing to give the speech, during the time they give the speech, and to make it even worse, when they're done with the speech, we make them do this hard math test, like counting backwards from 100 by 7s or something like that. This is just the cortisol response. So if you look here, these 2 lines represent, over the course of the study, the institutional group, care as usual group, and the foster care group are showing no elevations in cortisol, in contrast to the line up here, which are the kids who've never been institutionalized. So at first glance, this demonstrated that being in an institution early in life leads to a dysregulation of your cortisol response, and that there's no foster care effect. But when we divided the foster care sample in placement before or after 24 months of age, you'll notice the solid black line are the kids placed in foster care before 24 months of age, and it's identical to the kids who've never been in an institution. So again, like we saw with the EEG, we have a critical period. Kids placed before 2 have a normative response. Kids placed after 2 do not. So, children raised in institutions during early development demonstrate significant impairments in physical, cognitive, language, social, emotional, and brain development compared to community children. Our model of foster care as an intervention appears to ameliorate many of the negative sequelae of institutionalization, but not all. We had no effect on some executive functions. We could not diminish the prevalence of ADHD, which is about 20% in our sample. Whether this is because we place kids relatively late or not, we're not sure. Overall, children removed from institutional care and placed into high-quality foster care show dramatic improvements relative to those who remain in institutional care. And unlike many studies of early intervention, we see no washout. That is, all the way through age 12, we still see intervention effects. So, in conclusion, exposure to adverse early events can lead to both short-term and long-term consequences on physical, psychological, and behavioral health, and this in turn can impact not only the child, but also the family and ultimately all members of society. So the take-home message is, let's reduce the burden of harm done to children by limiting exposure to early adversity and putting an end to institutionalizing orphans or abandoned children, and developing more effective treatment strategies that can be used both early in life during critical periods, but also perhaps later in life after a critical period has passed. And on that note, I think I'll stop and take some questions. Thank you. There is recent work that has pointed the way to recovering a critical period. So an example of that would be a child who's born with their eyes crossed and do not have that corrected when they're little. So they always have an eye that wanders, or they can't converge on an object, and they will always have a visual problem. There's some recent work to suggest that there are drug treatments or a behavioral treatment that can treat this in the adult. Another example of this is work done by one of my colleagues, Takao Hench. Perfect pitch is something that if you're going to have it, you're going to have it very early in life, and you can't teach it. They did a drug trial where they gave non-musicians who don't have perfect pitch a drug that affects the inhibition of neurons communicating with one another. And these adults learn to acquire many aspects. What we need to do is figure out, for a child who's gone through the critical period, are there ways of reopening that critical period and successfully intervening? We don't have those ways yet. There's at least one person in the audience who's a child psychiatrist who can tell you that if you're going to successfully treat children with conduct problems, disruptive behavior disorder and things like that, you're better off doing it when they're little than if they're teenagers. But inroads have been made in more effective treatment strategies for teenagers. So the implicit issue here is not to give up. If a parent said to me, listen, I'm thinking of adopting a kid who's 5 and has spent the first 5 years in an orphanage, is that a mistake? I would say no, it's not a mistake. Just be prepared that that child's probably going to have some developmental challenges, and it's going to take a lot of work, and they may never come back to even keel, but they will make gains. They just may not recover fully. What has been done about dealing with adults who've had these adverse early experiences? Think of standard psychotherapy. So there are many forms of therapy, like cognitive behavior therapy, one example, that are very successful in dealing with certain disorders like anxiety or depression. So here's an example where you've taken an adult and given them new ways of thinking and understanding their feelings that is very successful. And clearly we know the brain has been changed. But we haven't made enough progress in dealing with those issues. So one of the things that I endlessly tell my colleagues is that they need to understand and screen for adverse life experiences. So an example would be roughly 8 or 9% of the US population of kids have ADHD. Is that a fair figure? But not all, and 1 in 68 will have autism. But that doesn't mean all forms of ADHD and all forms of autism are the same. Some may have a developmental history that raises the risk of developing those disorders. By understanding that developmental history, you may change your treatment strategy. So kids coming out of the foster care system, for example, and we have terrible provisions in this country for when kids graduate from foster care, let's say at 18. Not enough attention has been paid to that. There are some experimental trials, for example, of experimental foster care that are very successful, but nothing has been brought to scale yet. And so I think we know what the problems are, and we have some ideas about what to do, we just haven't done it yet. So let me rephrase the question this way. So can we use imaging, in a sense, to look at whether there's a signature or a telltale sign of these early experiences? And then I'll go one further and say, can you use imaging to evaluate the efficacy of an intervention to see if you've changed the brain? And the answer is yes to both of those. So there's a lot of attention being paid right now to both functional and structural MRI as well as EEG to look at whether there is a residue, in a sense, the way an archaeologist would look at this, in the brain. So in fact, I'm part of what's called a toxic stress network designed to look at whether or not we see a signature at multiple levels of early adversity. So by multiple levels, the brain's electrical activity as well as dozens of biomarkers. They can be inflammatory markers, they can be hormonal markers, they can be marks in the epigenome. And so all of those things are being done. But the challenge, and I think this kind of comes back to the way I first heard your question, is relating all that to behavior. And right now that is moving in the right direction but imperfect, meaning that we don't always see this perfect association between the biology and behavior. That may mean we have the wrong measures, or it could simply be that sometimes they're simply misaligned and one is more sensitive. So for example, I think that our brain-based measures are more sensitive in detecting differences in going on in brain development, but they may not have functional consequences quite yet. So that's a very exciting area of research right now, coupled with also developing animal models of those things. So again, with my colleagues, for everything we do in the human, they also model that in usually the mouse, sometimes the monkey. So the question is, one part of it is how would we define neglect, and in not extreme cases like what I talked about, how would we identify or recognize neglect? And I have to smile when I think of this question because I live in Newton and my neighbors all think they're neglecting their kids because they're only going to like 3 sporting events and taking 3 AP classes. So one way we've approached this is to think, what are the kinds of experiences that as a species we simply expect to have? Sensitive, consistent caregiving, someone really to invest in us, someone to challenge us linguistically and cognitively, someone to help us regulate our emotion. I once asked at one of my lab meetings with all my Ivy League trained students what they think an enriched experience would be, and they said, well, you know, horseback riding lessons and French lessons. And I had to point out that, you know, before we had cars, we rode horses, and there are people who speak French that, you know. So we tend to think of enrichment as the counterpoint to neglect, and I think that's a mistake. I think that we recognize neglect when basic needs are not being addressed. So a family that's deeply invested in their kids can have 7 kids and be wonderful parents to all 7 kids, and there can be a family with just 1 kid that are being profoundly neglectful. So I think the way we like to think of this is an issue of basic needs, and whether children are growing and thriving in an environment where they feel loved and wanted and invested in. I don't think we want to go as far as saying they need to have French lessons and, you know, horseback riding lessons. Does that kind of help? I say it that way because parents feel so much pressure to be perfect parents in many ways, and I want to reassure them that, you know, the extra stuff can help tweak and improve things a little bit, but it may not make your child a healthier and happier adult. The question is, would a child growing up in a poor home who may be neglected, can one mitigate or offset the negative effects by, say, a teacher or a grandparent or a neighbor? Absolutely, and there's a lot of evidence to support that. So children are resilient, and there are protective factors that even in the face of risk can mitigate harm, and that often plays out. I mean, your example actually is the perfect one. A teacher steps up and really steps up and takes responsibility for a child who's maybe not getting much at home, and that can make all the world of difference for that child. The worry some of us have is that that needs to be maintained, and so if a child is coming from a really neglectful home and they have a first grade teacher who really looks after them, but then never see that teacher again, those gains can be undermined. And so we need the continuity. And the downside to many of the early intervention programs like Head Start and others when kids were little is they were spending, you know, 20 or 30 hours in Head Start, but they were going home to these very neglectful homes and impoverished homes later, and that's why the effects probably didn't stick. So we need to have continuity over time. How would we tell the difference between a child who is neglected and a child who has autism and a child who is neglected and may have features of autism? Okay, so first, if we just polarize the two and say neglect versus autism, very different phenotypes or behavioral characterization. Children with autism tend to be, they lack interest in the social world. They may have stereotypies, they may have restricted interests, they may have diminished language ability. A child who's neglected may well show what we call indiscriminate behavior. They're very sociable, but indiscriminately so. They'll go up to complete strangers and sit in your lap and walk away with you. In fact, if I brought you to the institutions that we work in, kids you've never seen before will just become incredibly social and friendly towards you, but it's indiscriminate. You shouldn't do that to a complete stranger. Now, what's interesting about your question is, in our study, 5 to 10% of our kids in orphanages have autism, but we don't think it's the same autism that I study here. So we had a monkey model of this, and we see it in humans as well. Profound neglect can lead to some features of autism, like stereotypies. I can show you videos of a whole group of kids rocking away or hitting themselves, but we don't think it's real autism. You can develop features of autism from neglect, but when looked at carefully, in fact, a colleague in Great Britain has referred to it as quasi-autism, because it doesn't quite feel like conventional autism. So does that help? Is there a way to help kids who've experienced adverse experiences gain insight into their developmental history and their current behavior? That's a really profound question. In the case of kids growing up in profound neglect, the challenge is that the kids often have very diminished intellectual capacity. So in our case, in our study, the average IQ hovers between 65 and 75. The kids just don't have the intellectual bandwidth to have insight and be self-aware. But for kids who've had other forms of adversity, not neglect, I think that would be the goal of some forms of psychotherapy, right? To help children understand their history. So an example is, I have an undergraduate who, by the time she was 6, was homeless and living in the back seat of a car with her family. And she was able to overcome that with a lot of help to gain insight into how she became the person she is today. The concern is this is not available to everybody. So I think there may be ways, and again, we can talk to someone in the audience about this, but I think there are ways to help kids like this gain this insight, but I just wish it was more widely available to all kids experiencing adversity, and it's probably not. Are there any aspects of Head Start that would increase its efficacy? So before I address that, let me rewind the tape for just a second. If you looked at the cognitive gains made in Head Start, those are what washes out. But in some of the more sophisticated intervention programs, one is called abecedarian, the cognitive gains washed out, but there were these sort of intangible gains. So the rate of incarceration, high school dropout, conceiving a child, as a teenager, all of those things were reduced for the kids placed in the early intervention. So one thing that people have thought of that would make them more efficacious is to have continuity from the intervention to the home. So the example of that would be, I have a project in Sao Paulo, Brazil, where we're targeting 12 to 15-year-old girls who are having babies. And starting the second trimester of pregnancy, they're visited every week by a skilled nurse, basically to teach them about children, and that continues for the first several months after the kids are born. And the hope is to instill in them a better sense of mastery. But then what has to happen is that we need to continue some kind of a support program for those girls long after they've had those babies. So the problem is that if we just give kids a dose of an intervention but do nothing at home or in the neighborhood, we can pull out the rug from underneath ourselves. So that's one way to do that. And the second is, now that we know a little bit more about the kind of signature we see from kids growing up in adversity or poverty, we can target those things. So executive functions would be an example. So some efforts have now been made in these early intervention programs to specifically target things like the ability to inhibit an impulsive response, or to be more planful in your behavior, like count to 10 before you do something. Thank you very much.
How do we make our feet strong and healthy? So I think the best thing we could do is, if we started out as kids and didn't put shoes on and wore open-toed sandals and really let our feet develop as much as they could, I think that would be the best thing.